intervals and behavior and transformations of parabolas. There's a quick warm-up here. I want you to complete the parabola. Go ahead and press pause and hook that up, or you can watch and see how it goes down. So the vertex is down here. That is the point -4, -6. And we've learned about the axis of symmetry. That's where it's an imaginary line where it's the same on both sides. So the axis of symmetry there is a vertical line going through the x point of x equals -4. So because it's symmetry, it's the same on both sides. So this point right here, if we were to reflect it across, would be on the other side right there. Here's another point they seem to have given us. 1, 2, counter over 1, 2 this way. So this parabola, I didn't draw it the best, but you should still want a parabola just like this. Drop it down, pick it up, just like this. That's a little Iggy for you. She rhymed like this with like this. That's not a rhyme. It's just saying it again. Just not so fancy. Anyways, the equation. This one's a little bit trickier. The vertex form is y is equal to, since we have the vertex form, we know it's going to be x plus 4 minus -4, quantity squared, and then -6. The question is, what is a? Well, here's the thing. Because for this first run over, a is pretty much whatever the quote-unquote slope is of the first one, but it's got to be divided by 1. So in this case, since it goes up 2 and over 1, a is indeed 2. Now, if it only went up a half and over, then it would be a half. Wide parabola is a little bit trickier to tell, but that was just a little challenge for you. There it is. All right, so back in the beginning of the year, or in Algebra 1 at least, we talked about writing an inequality for these. For example, this one would be x is less than or equal to -2. This one here, this is an interval. It goes between -2 all the way up to 5. And since it's a dumbbell, this is an and statement, or an interval. So what we can do is write -2, x, and 5. Now we know that x is less than 5 because it goes down this way. But we also know that x is greater than or equal to -2. So if we were to write that backwards, x is greater than or equal to -2, looking like that. Now, if you wrote it as x is less than 5 and x is greater than or equal to -2, it's not that that's wrong. This is a little bit better notation. But now we're going to learn a new type of notation to write something like this. This x is less than or equal to -2. That means we start at -2 and go to the left all the way to -infinity. If going that way. Another way to write this, I'm going to write this one here is going to be parentheses 5 comma, so this goes from 5 all the way up to +infinity. You get a nice little announcement there. 5 to +infinity. This is called interval notation. Now, while it looks like a coordinate pair, there is no infinity for a coordinate pair, right? Let's talk about the next one. Now, how would I write x is greater than or equal to 5? That's very similar to this one. It's going to be 5 with a bracket, comma, +infinity. All right, before we go further, let's define the difference between a parentheses and a bracket. A parentheses does not include. So for example, if we had greater than or less than, we would not include, so that would be a parentheses. A bracket does include, i.e. less than or equal to, greater than or equal to, or even an equal to. We would include those. Now here's the thing, infinity is always going to use parentheses. Infinity always going to have parentheses. It's never going to use brackets. So let's talk about this one. This one is going from 5 less than, but it's going to be open dot that less than. So reading this from left to right, where are we starting? We're actually starting at negative infinity and working our way up to 5. Now, is 5 going to be a bracket or a parentheses? Should be a parentheses because we are not including the 5. All right, so then this one, again, starting at, if we were to do 5 less than, reading this from left to right, we're starting at negative infinity again. Remember, infinity always gets a bracket. And it's going up to 5, but we're going to put a bracket on it. Okay, now this one's a little bit different. This one, we're going from negative 4, open dot, to 5. That would be a closed dot. Looking like that, right? So we're starting at negative 4 and working our way up to 5. So negative 4 up to positive 5. At negative 4, are we including that? Nope. So it would be parentheses. What about the 5? The 5 would be a bracket. So interval notation is just a little simpler way of writing something like we did up in these two examples. While it might look like in ordered pair at times, you got to consider the context. So here's the thing. Take a second. Let's go back up to these two. Write these two in interval notation. Go ahead and press pause and give them a shot. Hopefully you got something like this. There it is. All right, page 2. End behavior. End behavior is talking about as we walk along the x-line towards infinity. What is the graph doing? Where is it going in terms of y, in terms of up and down? So let's talk about this first one. This notation says as x approaches positive infinity. As we walk across the positive x-axis, the graph, what is the graph doing? Well, as we go across here, the graph is going down. So what is f of x? Another name for that is y. What is y approaching? In this case, it's approaching negative infinity. As we go to the right, this is going down. Now let's go to the next one. As x approaches negative infinity, we start at the origin and we go towards negative infinity. That's to the left here. What is our graph doing? Well, it's going up. So it's approaching positive infinity. Approaching positive infinity. This is just a weird notation, just asking you to look at the graph and determine what's happening here. Let's look at this next one. As x approaches positive infinity, as we go across the x-axis, right here it goes down for a bit and it comes back up. But as we keep going along x, what is the graph doing? The graph is approaching positive infinity. It keeps going up. Let's talk about this one. As x approaches negative infinity, as we go across the negative x-axis, yeah, it wiggles for a bit, but then the end behavior, we're only talking about the ends. The end is approaching, this case is also approaching positive infinity. Just look at the graph, determine what the end is doing, which directions it's going. If it's going up, it's approaching positive infinity. If it's going down, it's approaching negative infinity. Let's talk about this last one. As x approaches positive infinity, what is the end behavior? Well, the end behavior is going down to negative infinity. As x approaches negative infinity, as we go to the left, the graph is going down. So that also approaches negative infinity. End behavior, you just look at the graph and determine what is happening at the end. All right, so that brings us to transformations, vertical stretch and shrink. And this is actually something we've done, but now we're just going to give it a different name, a different type of terminology. Given this vertex form, we've talked about how H and K are the vertical and horizontal shifts. But one of the things we haven't talked about is reflections. For a parabola that opens down, that means when A is negative, right? When A is negative, the parent graph has been reflected over which axis has it been reflected? If it's opening down, it's been reflected across the x-axis. Now, another thing we're going to talk about, a wide parabola can also be considered a vertical shrink. By a given factor. It's a shrink by a given factor. Here's the thing, y'all. That's when the absolute value A, whatever A is, forget about the negative. The negative is just talking about the reflection. When A is less than 1, then it's a shrink. All right, so a wide parabola where A is less than 1 is a shrink. While a narrow parabola is considered a vertical stretch. We're stretching it up. There's a bell. Where the absolute value of A is greater than 1. That is a stretch. So let's put all this together. Here's an example. We have a vertex form here. Since it's negative, this opens down. It is wide because 1/3 is less than 1. So because it's less than 1, as we just learned, this is a vertical shrink because it's less than 1 by a factor of 1/3. The vertex is the point -3, -2. So let's plot that point, -3, -2. And the axis of symmetry would be a vertical line going through that. So that would be the point x equals -3. The y-intercept. The y-intercept is always the point 0, something. So I'm going to plug that in for x. 0 plus 3 is 3. Squared is 9. -1/3 times 9 is -3. -3 minus 2 is -5. So I plugged in 0 for x. Calculate that. 0, -5. Now, from our warm-up, we talked about how parabolas are symmetrical. So this point here, since this is 1, 2, 3 units away from our line of symmetry, 1, 2, 3, there's another point right there. And we could go and graph this inside our calculators and figure out stuff, but generally it's going to look something like this. Ooh, by the way, remember how I talked about over 1? This would be down 1/3 and over 1. That's what that point would be, but that's not important. X-intercepts, as you can see, there are none. It never crosses the x-axis, so there's none. Now let's talk about the increasing interval. This is a new thing. So as we go from left to right on this graph, the graph is increasing, isn't it? So from negative infinity, this goes down forever. As we go from left to right, from negative infinity all the way up till -3. This is increasing from left to right. This graph is going up. Yeah. Now, from left to right, where is it decreasing? From left to right, this graph is decreasing from -3 down to infinity. So from left to right, -3 to positive infinity, it is decreasing. Smith, how come you didn't include a bracket at -3? Well, at -3 it's not increasing. In fact, that's where it stops. So that's why we're not including it in either one. End behavior. As x approaches infinity, as we start at 0 and go to infinity, our graph keeps going down, goes down to negative infinity. And as we start at x, as x goes to negative infinity, as x goes to the left, our graph is still going down. It's still negative infinity. So that's a application of our use of our interval notation and end behavior, and then our vertical shrink, the new stuff. Let's go on to the next thing. Now, when we're describing transformations, how a parabola changes from the parent graph, order does matter. The first things you have to list are the reflections and stretches or shrinks. Reflections and stretch shrink. Then after that, then you describe the shifts, be it vertical or horizontal. So for example, let's describe the shifts here. First of all, this negative, if there's a negative, that talks to you about the reflections. This 2 here, this is going to tell us whether it stretches or shrinks and by what factor it stretches or shrinks. Then hopefully this -3 is familiar to, this is the horizontal shifts. And then K is the vertical shifts. So if we were to describe what happened to the parent graph, if f of x is equal to x squared, if that's the parent graph, what happened here? Well, this got reflected across the x-axis because it opens down. It got vertically stretched by a factor of 2. I'm going to pause because the bell's about to ring. So we're going to go ahead and describe the transformation here. It was reflected across the x-axis, stretched by a factor of 2. Excuse me, we should be a little bit more precise there. Vertically stretched by a factor of 2. We'll learn more about horizontal stretches maybe later this year, possibly in pre-calculus. Then it was translated 3 units left, or excuse me, x plus 3 goes the opposite of what you think. Yeah, it goes left, 3 units left, and down 6 units. So just by looking at this equation, we can describe the transformations that happen to it. So what I want you to do next is press pause. I want you to describe the transformations here, if any. And then I want you to look at this, and I want you to, reading this description, make the translations. Go ahead and press pause. I'll put the answers up in just a moment. All right, check your answers. This one was shrunk by a factor of half and translated right 2 up 3. And then this one, since it was shrunk, it's 1/7. Reflection, it's negative, and then translated 4 be x plus 4 quantity squared. Bring your questions to class. Smith out!